Well, good morning and welcome to HDFS 7060 Research Methods 2. I hope you had a good break. I know this is not the traditional way that we start out a semester, and so I apologize. I hope you understand that as a chaplain that there are times when I am called to help soldiers out. It doesn't happen very often, and so in the past, 4 months, I've received 3 emergency alerts, but they've all been within the last 2 weeks, including the one on Wednesday. So I appreciate your patience as we get started here. I know most of you took 7050, and so you already know how this course kind of goes. I'm not too concerned there. And this first day, we're just doing some review. I think we're still going to be off to a strong start. I know after a break, it's hard to remember what we were talking about a month ago, which is why I want to use this one class here to kind of touch up back on regression, because this semester is going to be all regression. We're going to get into assumptions. We're going to check assumptions, make sure our models are performing the best that they possibly can. That way we're more confident in the results that we get. And that's primarily the focus for 7060. If you've opened up your syllabus and read it already, you've seen the schedule on there. You'll see that we're spending a lot of time with regression, whether it's issues in multiple regression or whether it's detecting and correcting violation assumptions. Whatever it may be, we're spending a lot of time in regression. So this is a regression class. We left off at 7050 just with simple linear regression, multiple regression, doing moderation models, and now we're going to take it a step further and get into the kind of nitty-gritty of what regression is all about. If you look at that schedule as well, you'll see that after spring break, we'll spend some time on factor analysis. We'll also learn how to do logistic regression, and then we'll finish up the course with an M+ workshop. That way you are better prepared for those 8,000 level classes that you'll need that M+ experience. And so that's really kind of how this course is going to go. I'll go ahead and let you read the syllabus. Like I said, that the structure of the course is very similar to what was with 7050. And so there shouldn't be too many surprises there. I do have to say that I think the difficulty level is a big step up from 7050. So you definitely want to make sure that you're staying on top of the class this semester. Can get away from you pretty quickly. All right, so let's move on just really quick here. So just a few things I just want to touch on. So if you're on the Canvas homepage, you'll see that the syllabus link is right there near the top, that you can go ahead and click on and download that syllabus. Make sure you have a copy of it. Make sure you look at it. We'll talk briefly about the syllabus when we come back next Wednesday, just to make sure we're all on the same page. Just like last semester, there is that exam study guide link. That study guide is going to look very similar to what we did at last semester. And then you'll see, just like last semester, you'll see our weekly class files and readings. They'll be listed there for each day that we're working. And so obviously 2 days ago on Wednesday, on January 10th, there were a few things that we're planning to do. So I'm going to ask that you get those done and completed before January 17th. And then you'll see that there is a reading due for January 17th as well, and a worksheet that goes along with it. So the very first thing that if you haven't done already, please do the pre-course survey. That is through the department. They like to get a pre and then a post about your experience in the course, what you're learning. And so go ahead and take that link and do that before you do anything else in the course. You'll see that there's an SPSS dataset link there. We're going to go over that today, go through a couple of examples, just to kind of refresh your memory of doing just some basic regression stuff and interpreting the output. So nothing too crazy today. I don't think it'll take too long, but just something to kind of get us back into the swing of things, because we're going to hit the ground running with regression. We'll do a little bit in ANOVA to get started, but then we're going to spend a lot of time in regression this semester. Then you'll also see a worksheet number 1. So let me pull that up here really quick. And so if you're looking at that particular worksheet, and again, if we can get this back by next Wednesday as well, I think I give you to the end of the day on Wednesday. This is just so that we have some data to work with for your assignments, but also for in class. And so what we're trying to do here is identify some variables that you can work with some actual data. Hopefully data that's something that you're interested in, either within your lab or for your thesis. Now, because we're collecting data in an educational environment and we have not gone through IRB, you can't use any of the data for presentations or your thesis or anything like that, but it's an excellent opportunity to do some pilot studying, seeing if your instruments are working, seeing if you have relationships there. And so even though you can't take it outside the class, right, you can still use it to get some valuable information as you move forward in your research projects. So this worksheet is requiring you to identify 5 variables. If you notice, it'll say that that they can be single item variables if that's what you want to measure. But you do have to have at least one instrument. So one validated instrument that we could use later in the semester to do a factor analysis on. And so it doesn't particularly matter to me what instrument. It doesn't matter to me if you use multiple instruments. My only requests are that because we're going to be asking undergraduate students, that the questions cannot be too sensitive because we're not going through IRB. We're just using it to learn how to do analyses within the classroom. And so it can't be anything too sensitive. So don't ask about things like sexual practices or anything like that. That's too sensitive. Don't ask about drug use. That's too sensitive. So, but everything else that you can think of that you may want to ask that's not too sensitive, feel free to do so. And if there's any question about whether or not it's too sensitive, just let me know. Just ask me, if it's a question or questionnaire that you can use for data collection. But at the end of the day, we want to be able to have 5 variables. And so if you're using an instrument that has like a 10-item instrument that you're going to use as a sum score or an average score, as a composite score for one of your variables, that's perfectly fine. And you can have multiple instruments, but limit it to 50 questions because there's 12 people in the class and everyone's asking 50 questions, right? That's 600 questions for me to ask to the undergraduate students. And that can be a lot and can be overwhelming. So, so limit it to 50 questions for your variables, and we should be in good shape. Now, ultimately, you do want to identify a continuous outcome variable, and then at least 4 predictor or covariate variables that you use for analyses throughout this semester. Now, these assignments are not going to be like the last semester. They don't build up into one big assignment. They're going to be 5 standalone assignments, depending on what we're working on that particular section of the course. So it's not going to build on itself. Each one will be its own individual paper, its own individual analysis. So you end up doing 5 analyses over the course of the semester. Okay, so that's worksheet number 1. So be thinking about those questions. That shouldn't be too hard because I'm sure you're already working in your labs with generating questions and thinking about thesis and stuff like that. But get about 5 variables. When you submit it to me, make sure it's in ready to go format that I can just copy and paste into Qualtrics. That'll save me some time. If it's not, I'll send it back and tell you to put it in copy paste format so I can just drop it right in. Okay, so that's worksheet number 1. So please have that done by next Wednesday. Again, if you need to do it after class on Wednesday, that's perfectly fine. The other things that are due for next Wednesday is a reading. It's not a particularly long reading, but the Cunningham article. See if I can pull that up here. So relative weights comparison of trauma-related shame and guilt as predictors of the DSM-5 post-traumatic stress disorder symptom severity among U.S. veterans and military members. And so we really want to be looking at this particular paper because our method section, if I can get down there, is going to focus on some linear regressions and how we can disentangle predictors that are highly correlated with each other. So not very long either. So it looks like it's about, if you don't include references, it's about 10 pages, so that shouldn't take you too long. There is a corresponding worksheet with it as well. Some questions to help you guide you through the article. And you notice that these questions are essentially a review of 7050. So you're going to look at the article, you're going to read the article, and then think back what you learned in 7050, right? And then answer the question. So everything here is related to something you learned in that last class last semester. And again, another good way just to kind of get caught up, get your mind thinking about regression again. So I definitely recommend looking back at your notes if you have any particular questions, you can ask as well as you're working on the worksheet. Now this one is due before class, so as you come into class, if you can have this emailed to me before we start, I want to see where you're at, and then if we have time in class, we'll talk about some of these answers, or at least the ones that are most difficult for students to remember. So we'll touch on it a little bit, but do have it complete as possible and submitted before class begins. Okay, so I think that does it far as just what is due next week. Obviously, we'll get into some new material next week. This week, we just want to do some review. And so I have that SPSS data set there. So as you're watching this video, you probably want to follow along as well. Make sure that you remember how to do a regression and how to interpret the results. I'm just going to jump right into a multiple regression. Because the interpretations for a simple linear regression is very similar to interpretations for a multiple regression. So I don't see any reason to do a simple linear regression and then a multiple regression. Let's just jump right into a multiple regression and get some output and take a look at it. Okay, so once you open up that SPSS file, we're going to have, it looks like 5 variables here, not including the participant ID number. We used this data set once last semester. We used GPA as an outcome variable. I'm going to use happiness as an outcome variable for this particular analysis. And then we'll pick a couple of the predictors that we'll use for a multiple regression. And so we're going to use study, whether or not someone studies alone. We'll use that one. So that's the study column here with the zeros and ones. And then we're going to use spending money on alcohol, which is going to be this last one here. So if we're looking at these variables, I'll go down to the variable view. Let's just make sure we understand what these variables are. And so these are questions that were asked of students. And so for our study variable, it just asked, do you study alone? And in this case, if you studied alone, the code was 0. If you studied with other people, the code was 1. Our happiness variable, which is going to be our outcome variable, is generally how happy are you? It is on a 7-point scale from very unhappy to very happy, where higher numbers means more happiness. And then that last question is, how much do you spend on alcohol per week? And this is just an open-ended response where they indicate the dollar amount. So we have some people spending $80, some people spending $5, right? It's going to vary depending on the particular student. I think the highest amount is $100 per week on alcohol. So just get an indicator how much money is being spent on alcohol. Maybe that's an indicator of how much someone drinks. Maybe it's also an indicator of how much someone is social, right? You're spending more, you're being more social. Again, it's just an indicator of some larger function. All right, so let's go ahead and jump into the analysis. So if we go up to analyze, go down to regression, it's going to be a linear regression. And of course, as we go through this, feel free to pause, right? At any moment, you can always go back and rewind it a little bit. So if I go a little bit too fast, that's okay. All right, you have the power to pause and rewind when it comes to this particular demonstration. All right, so our dependent variable is our outcome variable. So we want that to be our happiness variable. We'll drop that in there. We do have a couple of independent or predictor variables. We want to know if they are studying alone, how that might impact their happiness, and then also how much they spend on alcohol per week as an indicator of maybe sociability or maybe an indicator of drinking, how much they drink, right? So if you're spending money on alcohol, you're probably drinking that alcohol. So however you might use it as an indicator for, again, you know, when it comes to quantitative analysis, right, we get the how, but we don't really get the why, right? And so we describe what's going on, but we may not necessarily know exactly what is impacting happiness. But we have our two indicators there. Now, we're not going to worry too much about the save option yet. We'll get to that later in the semester when we're looking at assumptions. But I'm just going to go down to options here really quick. We don't need anything there. Oh, let's go to statistics. We do want those confidence intervals. Let's go ahead and get our descriptive statistics. That way we get some correlation matrices. We're not going to worry about part and partial correlations or collinear diagnostics yet. We will get to those this semester. So we're just going to do a review from last semester. Click continue. We're not going to worry about any graphs yet, but we will get there this semester as well. So you'll find that as we get into regression, that we are going to go more in depth and check those assumptions and scatter plots to make sure that we're meeting our assumptions as best as we possibly can. That's really one of the goals of this semester. All right, so let's just click OK. Let's get some output here. Let's take a look at it. Of course, we're going to get those general descriptive statistics like means and standard deviations at the top. I'm not going to worry about that here in this particular example. But let's go down to this correlation matrix. So the correlation matrix does give us an idea bivariately how each predictor relates to the outcome. So it's not in combination, but individually in pairs. If we're looking at our significance levels, when it comes to happiness, we'll see that studying alone is a significant predictor. That significance value is less than 0.05. And same thing on spending on alcohol is less than 0.05 as well. But primarily what we're really concerned about in this particular correlation matrix is the correlation between the two predictors. We're interested in collinearity. We don't want to have collinearity. We want our predictors to be as independent as possible. So if we see a high correlation among the predictors, then that could indicate multicollinearity. And as we talked about last semester, that can cause your slope coefficients to be unstable. It can inflate your standard errors and make you less confident in your results. All right, so our two predictors here is studying alone and how much you spend on alcohol in a week. So if I look at do you study alone, and then I follow it to where it goes to our other variable of how much you spend on alcohol per week, we see that there's a correlation value of 0.136. It's a non-significant correlation, but as an effect, 0.136 is a small effect. Not particularly concerned about collinearity here. All right, that value is less than 0.4. Obviously, the higher that value, the more concerned we are. We do see collinearity issues at values of 0.4 or higher when it comes to a correlation. So this is below that. We're not too worried about the stability of the regression coefficient. It should be fairly stable. We're not really concerned about inflation of the standard error. Now there's always going to be some, right? Because even with chance correlation, there's going to be some fluctuation, but nothing to be overly concerned about. Okay, let's go down to, we have 3 boxes here that we're going to take a look at the bottom. Let's start with the ANOVA box and the output. So this is just overall for the model, right? You notice you have 2 degrees of freedom here. We have 3 variables, right? The 2 of those variables are free to vary infinitely. And so that's going to be with both of our predictors in the model. And if we look at our statistics, we see we get an F statistic of 7.019. The probability of getting that F statistic or 1 greater is 0.002. So this is our p-value. So again, remember our p-value is the probability of obtaining the test statistic. In this case, that test statistic is the F statistic, 7.019, or 1 greater than 7.019. So the F distribution is a positively skewed distribution. You only get positive values, right? And so, the probability of getting this F statistic or 1 greater is 0.002. That p-value, that probability value, is less than what we would generally use as an alpha of 0.05. And so it does look like overall that this model is significant. So if the overall model is significant, then we can look at the individual predictors, just like we would with a post hoc test for ANOVA. And go down to the coefficients down here to see, well, which predictor or predictors significantly predict, in this case, happiness for our particular students. All right, so let's go through our coefficient box here. We'll talk about interpretations as well. You're going to see that we do have a constant. That constant is 5.914. We're not particularly interested in the constant by by itself. We're more interested in individual predictors. So we're not going to interpret whether that's significant or not. But again, that constant value in our equation is that y-intercept. So when both of your variables are at 0, where does it cross the y-axis? It looks like it's going to cross the y-axis at 5.914 for that regression line. All right, and then we have our two variables. Do you study alone, and how much do you spend on alcohol per week? And so that very first one, do you study alone, was a categorical variable. Remember, it was a nominal variable. Either you study alone or you study with others. That unstandardized coefficient is 0.717. So we'll talk about that here in a second for that interpretation. If we go to the t-statistic, we get a t-statistic of 2.91. The p-value, or the significance value in this case, is 0.005. Again, less than an alpha of 0.05, so we would say it looks like whether you study alone or not is a significant predictor of one's happiness. So we'll interpret that here in a minute. And then you're going to see our coefficient here as well. I'm sorry, our confidence interval over here as well, and it ranges from 0.227 to 1.207. So we'll interpret that one here as well. So significant predictor. Let's talk about these values here. I'm going to talk about this in terms or in relation to the constant. So you see the constant here is a value of 5.91. If we were to interpret this constant, we would say this constant is the mean value of happiness, right? When a student is studying alone. So remember that constant represents the mean when you have a nominal variable of the value that is coded as 0. And so remember, 0 in this particular case, for whether someone studies alone or not, indicated that a 0 would be they study alone. And so we would say their happiness score is 5.914 on average as a mean. Again, when how much you spend on alcohol is accounted for in the model. You can't forget that other variable. So this would be our mean for students who study alone and their happiness level when the amount spent on alcohol is counted into the model. All right, so do you study alone? That variable now represents those that are saying they study with other people, so they don't study alone, so coded as 1. What is the change in happiness? And so that change in happiness as you go from 0 to 1, being alone to being studying with others, is 0.717. So what we're saying is that if a student is studying with other people, their happiness increases 0.717 units on our scale, our happiness scale, again, when the other variables are accounted for in the model. Again, that other variable being alcohol spent per week. So remember, if your predictor variable is a nominal variable, dichotomous variable, the constant represents the average of the group that is coded as 0, in this case, studying alone. And then the variable tells you, the coefficient here for your variable tells you the change as you go from 0 to 1, as you go from studying alone to studying with others. And so in this case, studying with others increases happiness 0.717 on our scale on average. And so that's how we would interpret those standardized coefficients. And again, studying with others versus alone was a significant predictor, where if you're studying with others, you tend to be reporting more happiness, at least in this particular sample. Let's see, let's interpret the standardized coefficient. So the standardized coefficient here, again, is in terms of z-scores. So what we're saying here is that a student who studies with others is going to see an increase in happiness of 0.29 z-scores over those who study alone, so an increase of 0.29 z-scores. What's nice about the standard scores is that you can compare them to other variables to get a relative weight of how that predictor variable is impacting your outcome. However, when it comes to interpretation, no one talks about anything in terms of z-scores, so it's not particularly effective if you're trying to communicate what you're learning. You want to talk about your unstandardized coefficients in that case. But again, its purpose is more to compare relatively to other predictors rather than to explain it to another person. Let's talk about those confidence intervals really quick. So again, based on the data, based on our sample, because everything is sample dependent, that unstandardized coefficient was 0.717. So in other words, the increase in happiness when studying with others is 0.717. That is our best mathematical guess given the data we have in our sample. In the population, it could be higher than that, it could be lower than that. And that's what that confidence interval gives you. It gives you a range of where that true population difference is going to fall, 95 with a 95% chance. So here we would say there's a 95% chance that the increase in happiness for students who study with others is between 0.23 and 1.21. So again, that confidence interval is not a hypothesis test. I know some people use it as a hypothesis test on whether to reject or fail to reject a null. And you can do that as long as you have a two-tailed test. If you have a one-tailed test, then there are situations where it won't work. But that's not its purpose. The purpose is to give an estimate of the population parameter. In this case, the change in happiness between those who study alone versus those who study with others. Our best guess, again, 0.717 given the data, but in the population could range as low as 0.23 as an increase in happiness, or as high as an increase of 1.21. And I'm saying increase here because they're both positive values. Okay, so what if your predictor is a continuous predictor? As you might remember from last semester, that changes how we talk about the coefficient. So in this particular case, our other predictor is how much money do you spend on alcohol per week? And we get a coefficient of negative 0.014. And so when we're interpreting this particular unstandardized coefficient, we're saying for every 1 unit change in the predictor. So in other words, for every $1 spent on alcohol per week, how much would we expect happiness to change? Right? So for every 1 unit change in your predictor, what is the impact on the outcome? So for every $1 spent on alcohol per week, how would we expect your rating of happiness to change? You're going to notice here that it's a negative value. And so in other words, happiness is going to decrease. It's going to decrease by 0.014 of our happiness scale. So for every dollar spent on alcohol, we were expecting happiness to decrease negative 0.014 on average. Now, of course, this is multiple regression. So when we say that, we're saying when the other predictors are accounted for in the model. So if we were to do alcohol, this predictor as alcohol by itself, we may get a slightly different coefficient because we have other predictors in the model. So in this case, every dollar spent, we expect happiness to decrease 0.014 on average when all other predictors are in the model. So in other words, whether you're studying alone or not is in the model, it's accounted for. If we look at our standardized coefficient here, we get a negative 2.76. So again, this is in terms of z-score. So we're saying for every 1 z-score change, so notice I'm going to use z-scores here, for every 1 z-score change in spending on alcohol, we are expecting a negative change, z-score change, a negative z-score change of 0.276. So just note that our interpretation is pretty much the same, except we're going to say z-scores rather than using the raw units that we use with the unstandardized coefficient. So again, unstandardized coefficient is good for explaining the relationship and the change in that relationship. The standardized coefficients useful for comparing to other predictors and the relative weights of the model. If we look at a significance value here, that p-value is 0.008. Again, that is less than 0.05. So we would say that this appears to also be a significant predictor when it comes to happiness. So just notice that it's in the negative direction. The more you're spending on alcohol, whatever we might say that's an indicator of, right? We don't know exactly, we just know they're spending on alcohol. The more you're spending on alcohol, the less happier you tend to become. That confidence interval is interpreted very similar to what we did earlier with that confidence interval. So remember that everything is sample dependent. If we were to get a different sample, we would get a different coefficient, right? That's because it's all based on who you collect data from. And so this is our best indicator for the population parameter, but it's not the population parameter. It could be higher, it could be lower, and that's what that confidence interval tells you. It gives you a 95% chance of where you would expect the actual population parameter, in other words, the change in happiness given every dollar of alcohol, to be. So in this particular case, we're saying that there's a 95% chance that for every $1, we'll say increase in this case, every $1 increase in spending on alcohol, the decrease in happiness can be as low as negative 0.024 to as high as negative 0.004. That's somewhere in there we would expect the true population coefficient to fall. So again, not a hypothesis test. That's not why we get confidence intervals. Confidence intervals are there for us to estimate where the population parameter, in this case the population coefficient, regression coefficient, might be based on what we sampled with the data. Okay, so those are individual coefficients. So they both look like they are significant predictors. Make sure that you're able to interpret those unstandardized coefficients, the standardized coefficients, as well as the confidence intervals. Let's go up to that model summary box. I saved that for last because that's the overall model. Once we know that our model is significant, we can look at the individual predictors, and then we can look at the overall impact. And of course, a few things in here that we care about. We care about that R-squared value. In this case, it's 0.14. So remember, R-squared is telling us the percent of variability accounted for in the outcome based on the predictor. So in this case, we would say it appears that 14% of the variation in happiness, so notice that people's happiness differs, right? Each person has a different level of happiness. That 14% of those differences can be accounted for by our predictors of whether or not a student studies alone and how much alcohol they spend per week. And then a 0.14 would be a large effect as an effect size. So 14% of the variation in happiness, students' happiness can be accounted for by whether or not they study alone and how much they spend on alcohol per week. So again, make sure you know the interpretation for an R-squared value as well. Okay, and then the last thing that we're going to talk about here in this particular box is going to be the standard error of the estimate. In this case, it's 0.96. So this is in terms of your happiness variable. And so what we're saying here is that for any one individual prediction, so any prediction for an individual student, there is a 68% chance that that prediction could be off by 0.96 units of happiness on our scale, right? So almost a full unit. If it's a 7-point scale, that's one of those scale units. And so just remember that that's in raw score, and again, it's telling us how far, again, it's error, standard error of the estimate, how far any one of our predictions could be off when we're interpreting for an individual person. So any individual, for any individual prediction for a student, there's a 68% chance that we could be off by 0.96 happiness scores on our particular measure. Okay, so that was kind of a crash course when it came to our coefficients and regression that we talked about from last semester. Let's go ahead, let's do one more. Let's do a moderation analysis and interaction analysis. I'm not going to use, I'm going to do it the long way, right? Instead of using process. Just so that you know where that's coming from, but also because it's easier to read as far as the output, and I don't plan on actually doing any type of review of how to graph interactions or anything like that. But let's create an interaction term, a moderation term here, and let's refit the analysis, and let's talk about what's different in that interpretation and what you need to look out for there, just as a reminder from last semester. Okay, so just remember that when we're talking about interactions or talking about moderation, what we're saying is that there's some relationship between a predictor and outcome that may change to some moderating variable. And so for our research question, let's just focus on our outcome being happiness, our predictor being alcohol spending, and how much someone spends on alcohol in relation to happiness might differ depending on whether they study alone or they study with others. That might be what we're particularly interested in knowing, that the relationship between alcohol and happiness might be moderated or changed based on whether or not a person studies alone or studies with other people. So the very first thing that we want to do is we want to create an interaction term. And we can do that by computing a variable. Quite literally, our interaction, I'm just going to put INT for interaction. Our interaction is literally our two predictors multiplied by each other. So I'm going to take our study variable and I'm going to multiply it. And again, the multiply symbol is the asterisk. Multiply it by our alcohol variable. All right, I'm just going to do INT for interaction here, or maybe I'll do this. I'll do S by A, right? Study by alcohol. And that X are just telling us all we're doing is multiplying these two predictors together. We'll click OK, and we should get our new interaction variable. In that particular interaction variable, we're now multiplying across whether or not they study versus their alcohol. So anyone who's coded as studying alone is going to get an interaction value of 0 because 0 times anything is 0. We're just walking through, just checking, make sure the math worked as it should have. And it looks like it did. 1 times 60 is 60, 1 times 0 is 0. So it looks good. So there's our interaction term. Just multiplying your two predictors by each other. Okay, so let's go ahead and do the analysis now. So we'll go to Analyze, we'll go to Regression, we'll go to Linear Regression, and it's already saving what we did before, and that's perfectly fine. In fact, I'm not going to change anything here. I still want my individual predictors in block 1. Those are my main effects. What I want to do here is I want to add my interaction term. So I'm going to go to this next button here. I'm going to click that. That's going to take us to block 2. And in block 2, I'm going to add my interaction term. I don't need to change anything in statistics, and I'm not worried about plots right now. We'll check assumptions later in the semester. But essentially what we've done here is we've built a model where we have the first block being our main effects, our two predictors by themselves, and then a second block of the interaction. I'll click OK. We'll get our descriptives as you see here. We'll get our correlations. Again, we're interested in the correlations that are higher than 0.4. If you're looking at that interaction term, you'll see that there are a couple of those correlations greater than 0.4 here. We have a 0.622 and a 0.496. This should not be surprising at all because your interaction term should covary with your individual predictors. It was created from them. It's not independent of them. And so we would expect high correlations here, which is why we do our two blocks, because we expect that the interaction is going to change the coefficients of our predictors drastically. We expect there to be fluctuations. We want to make sure we separate the interaction term from the two predictors terms in our analysis. Okay, so let's go down. So nothing surprising in that correlation box there. Let's go down to our models. We'll start with the ANOVA box just like we did before. And what we're particularly interested in is that second model. Is a significant model once we add that interaction term. Remember, the first model here is just the two predictors by themselves. All right, this is exactly the same as it was in our last output, just the two predictors studying alone or not, and then also alcohol spending. The second model has that interaction term in it. And so this is looking overall, is that second model significant? It looks like it is, right, 0.003. So what we want to do now is we want to go down to our coefficients box. We want to look at those different predictors and the interaction and see how they're relating to happiness scores. Now, we mentioned this last semester, so just this is a reminder, again, review, that when you have an interaction model, the very first thing you're going to look at is that interaction term. Right? You're going to skip to that interaction term to see if it's a significant interaction or not. And so let's go there. So model number 2, we're going to go down to our predictor variable is SXA, right? Study by alcohol. And we're just going to look and see, is that a significant predictor? In this particular case, our p-value, again, looking at that significance column, our p-value, probability value, is 0.25. So that's telling us in this particular case, the probability of getting a test statistic of 1.15 or more extreme, right, has a probability of 0.25, which is pretty high, right? So it's definitely higher than our alpha of 0.05. If you want a 5% chance, this is sitting around a 25% chance of getting a t-statistic of this value here, 1.15, or 1 greater. So that's not particularly rare, and so it doesn't look like we have a significant interaction here. It looks like it's non-significant, and so it doesn't look like our two variables are interacting with each other. It doesn't look like the relationship between spending on alcohol and happiness differs or changes based on whether or not someone studies alone or studies with other people. Although it's not a significant interaction, I do want to make sure we take a moment and interpret this unstandardized coefficient. So this unstandardized coefficient is 0.013. Remember, our interpretation of this coefficient is different. This interpretation of the coefficient is the change in the slopes when it comes to whether or not our students study alone or study with others. All right, and so remember that interaction is saying, does the relationship between alcohol spending and happiness change depending on not whether our students study alone or study with other people? And so if we were to graph those two regression lines, we'd see that the regression lines differ by 0.013. So the interpretation for the interaction term for our unstandardized coefficients is the change in the slopes. So remember before is for 1 unit change in the predictor with impact on the outcome. Here what we're saying is what is the change in the slopes between the predictor and the outcome based on the moderating variable, the moderating term. So in this case, the change in slope is 0.013. Okay, so let's go back as review. So we got our interaction term, we fit the model. We then looked at the interaction term to see if it was significant. If it was significant, then we would interpret the interaction and nothing else. Everything you would need to know would be in that interaction term. The relationship between the predictors would be in that interaction term. We could then graph it and visualize it. And so that's what we would do if we had a significant interaction. We don't have a significant interaction here, so then we would focus on the main effects. And I mentioned in 7050 that this is where a lot of researchers make errors when it comes to interpreting their models and then what they write up. Because your first inclination is to look and interpret the two predictor variables that are in model 2, the two main effects in model 2. And that would be incorrect. And it's incorrect because remember that the interaction term is made up of those two predictors. It's collinear with those other two predictors and it's violating an assumption. So if we were to interpret these two main effects using model number 2, we would look at it and say, well, it looks like only alcohol spending predicts happiness, right? But we failed to remember that those coefficients are unstable. The standard errors are being inflated because of that multicollinearity between those predictors in that interaction term. That's why we put this into 2 blocks. So one with just the main effects, just the predictors by themselves, and then another block or another model with the interaction term. And that allows us, if we fail to reject the null for the interaction, if we don't find a significant interaction, it allows us to go back to that first model and correctly interpret our predictor variables. So in this case, if we go back to that first model and interpret our predictors, we'll see that both variables, both studying alone or with others, and alcohol spending predicts happiness. So it's not just one or the other, but it's both. If we don't do this, right, and we interpret those main effects in the same model as interaction, then we're going to come up with a different conclusion, an incorrect conclusion, right, and saying that it's only alcohol that matters, but it's not. It's both, whether or not they study alone in alcohol spending. So just remember that, especially when you're reading papers and you see someone talking about moderation, they start talking about the main effects or the individual predictors. You know, are they using the predictors in the overall model with the interaction terms? If they are, then they're not interpreting correctly. So just remember that. Okay, so I know that's kind of a crash course in looking at output, doing regression analyses. It's hard to, cram an entire course into, one hour. But hopefully it refreshes your memory with some of the interpretation, with what to do with interaction terms, how to interpret interaction terms. And I hope that helps you kind of get refocused for this upcoming semester, because we're going to spend a lot of time in regression, a lot of time on assumptions, meeting assumptions, correcting for assumptions, right? And so if we don't have this basis stuff down that we learned in 70/50, then it's going to be a very, very long semester for you. You'll note that the worksheet number 2 is going to ask you some of these types of questions that we just talked about. Interpretation for the unstandardized coefficient, interpretation for a standardized coefficient, right? Interpretation for the effect size, those types of things. And so hopefully this review will help you when doing that worksheet number 2 as you're reading that article for next Wednesday. All right, so like I said, not the traditional beginning to the semester. I apologize for that. I don't anticipate emergency alerts very often. When they do, I do have to go because that is a soldier in trouble. That's a person in trouble, right? And we can always do this by, like I said, by video, or depending on the situation, by Zoom or something like that. So we'll be flexible this semester moving forward. As you have questions, make sure you get those questions answered. Hopefully you took notes as you're going through this particular video, or checking your notes that you have from last semester so that you're up to date and up to speed for when we get started next Wednesday. I wish you well for the rest of the week. I hope you get a good start to this semester. Enjoy your extended weekend. Don't forget the reason why we have it, right? Don't forget everything that we've done to advance civil rights in this country, and more importantly, how much more we need to do. So spend some time this weekend reflecting on where we're at as a nation, and where we're going. All right, I look forward to seeing you next Wednesday. Have a good rest of your week. Thank you.